Okay, let's get back to playing games and talk about poker. So, in the poker, there are 5 card combinations that are being chosen, and depending what cards are in this combination, something happened in the game. And one of the very natural questions is, what are the chances to get combinations of cards of different kinds that they call hands? So for example, a 3 of a kind is when you have 3 cards with the same rank and 2 other cards with other ranks. So before we start talking about how to solve this problem, let's first talk about what it means to say what are the chances. How do we define a chance? And we define a chance using the language of probability. In particular, here we will just talk about the finite probability. We won't really get into all the complicated distributions that, for example, physicists are using. So let's just mention a few terms and say what they are. When we talk about experiment, that just means we do something that produces an outcome. For example, we could draw 5 cards out of the deck and see what those cards are. Or we could toss a coin and see if it came up heads or tails. So in this case, an outcome is whatever the possibilities are, certain combination of cards or heads or tails. If you experiment with getting a lottery ticket, then your outcome can be a win or can be a loss or can be wins of different amounts. And the sample space of an experiment is a set of all possible outcomes. So for example, when you throw a coin, then it can come up heads, it can come up tails, and let's say there is no other choice, so the set of possible outcomes is heads and tails. If you roll, well, let's make it more interesting, rather than rolling one die, roll 2 dice at the same time, then your outcome is a combination of 2 numbers, each one between 1 and 6. And another word that you hear in probability a lot, an event, is a subset of outcomes. So an individual outcome can still be an event, a set of size 1, but an event is a little bit more general. For example, an outcome from rolling 2 dice can be that the first die came up 3 and the second die came up 6. But an event can be something like both dice came up even, or the value on one dice is a factor of the value on another dice, or they're the same, something like that. And generally, if you could, we're talking about fine probability, list all the possible outcomes, then event is just a subset of it. So now let's get to the main notion. What is the probability of an event? So now we know what we're talking about as experiments and outcomes. So first let's do the easy case. Let's define the probability of an event when all outcomes are equally likely. So you're throwing a fair coin, or you're drawing completely at random 5 cards out of a very well shuffled deck. And in this case, it's very easy to figure out what the chances are, because probability of an event is just the fraction of the number of outcomes in the event to the total number of outcomes. Again, here we're strongly using the assumption that all outcomes are equally likely. So for example, if you throw 2 dice and your event is that both come up even, well, this will happen in a 9 out of the total of 36 possibilities. So the probability of both coming up even is 1/4, 9 over 36. Again, this heavily uses the fact that we assume that every pair of numbers is equally likely. Well, every pair of numbers between 1 and 6. So more generally, probability sanity check is always a number between 0 which is when event absolutely cannot happen because a set of outcomes, for example, is empty, and 1 when event is always happens, and in this case you might as well take your sample space to be your whole event. And another useful thing to remember about probability is that if an event happens with probability, let's say p is some number between 0 and 1, then probability that the event does not happen, that is any of the outcomes in the complement of the event shows up, is 1 minus p. So let's now tie it to the combinatorics and show how we could estimate chances using just what we did before, counting things with this definition of probability. Let's get back to poker, and now let's restate our question slightly. So rather than saying what are the chances of getting a certain hand, let's ask how many ways are there to choose a certain hand. So how many ways are there to choose a 3 of a kind hand, or 2 pairs, or a royal flush? So let's just first look at the royal flush, that's the easiest one. The only thing to choose is whether it's going to be hearts or spades, or one of the 4 suites or diamond. And in this case there are 4 possibilities. They're all equally likely. We assume all the cards are equally likely, and therefore there are 4 different ways to choose a royal flush. Choosing 3 of a kind is a little bit more of a calculation, because first we need to pick the rank that will be the rank of those 3 cards that make it a 3 of a kind. Then we will need to pick what is it going to be out of the 4 possibilities, and then we pick the other then we are going to pick those 3 cards of the same rank out of 4 possibilities, and then we need to pick 2 other ranks, and then we will need to pick whether cards of the other ranks is again 1 out of 4 possibility each, like which one of them is diamond, which one of them is heart, or something else. And we end up on the order of about 55,000 possibilities. Sounds like a lot. Sounds like a lot more than getting a royal flush. So let's turn it now into probabilities. So now we have an experiment that we have a fully shuffled deck. Everything is absolutely random, and we are drawing 5 cards. So how big is the sample space? All the set of all the possible hands. Well, that's exactly the number of ways to choose 5 cards out of 52, and that's a little bit more than 2.5 million. An event of getting 3 of a kind is a little bit less than 55,000. So the probability of getting 3 of a kind is a little bit more than 2%. Okay, so far probabilities of every outcome in the sample space were the same. But think about that. If you define probability with all the outcomes being equally likely, then, for example, say you're walking down George Street, and what's the probability that you see a pink elephant? Well, you say, well, I just learned that all probability are equally likely. I either see pink elephant or I don't. Well, okay, would you really say that? Do you think that when you're walking down George Street, independently of how much you've been drinking or your friend been drinking, the probability of seeing an elephant is 1/2? And if not, how would you describe this in the language of probabilities?